Hello everyone, welcome for this lecture. Today we are going to discuss inverse Z transform. So now, if till now what we have studied is this signal which is x of n, its Z transform which is x of z. Okay. Now today we are going to take the inverse of this, which is where the signal's Z transform is x of z, where x of z's time domain of a discrete signal will be Z inverse of it gives us x of n. So this, to find out this one, we have a formula that x of n is equal to 1 divided by 2 pi j integration of x of z into z raised to n minus 1 into dz. But since it is a very tedious to carry out this integration, we are not going to use this one much. So we are going to use two methods for this to find out the inverse Z transform of a signals. So that those are partial fraction expansion method and another one is power series expansion method. In this case, we are going to study both. If they have specified in any by this method, particular method, then you can go for it, or any one among these can be used while solving the numerical. We'll discuss both of them. So today in this lecture, we are going to discuss only on the partial fraction expansion method. So let's see how that can be done. We know that partial fraction, so any signal can be expressed in terms of factors, saying key a by one factor and with the b by another factor. Okay, so x of z is equal to numerator divided by this denominator can be expressed like this, and then we have equated both the sides and then put some values to calculate a and b constant. So we are very familiar with the partial fractions, so let's deal with that. So before using it, there are few things we supposed to remember, that this signal, any signal of a Z transform is expressed in terms of b of z divided by a of z. You can say it is numerator by a denominator. Then remember b of z, that is numerator order of a z should be less than the order of z's order of denominator. Then we can go for a normal partial fraction expansion, a regular partial fraction expansion. Suppose if numerator has greater than or equal to your denominator's order of a z, then we have to go first by long division. Okay, we have to do a long division that brings us brings x of z to this level, that is b of z, which is numerator will be less than the denominator's order of a z. Okay, let's see what you mean by these all things by taking example. Let's take an example. Find the discrete time sequence x of n which has a z transform of x of z is equal to this. With the ROC they have said which is greater than 1. How we can deal? So let's take x of z is equal to minus 1 plus 5 z raised to minus 1. What we can do is, this signal can be by your calci, take off factors of this denominator, that is 1 minus 3 by 2 z raised to minus 1 plus 1 by 2 z raised to minus 2. So what we can do is, this z and this z square we can keep as it is, like 1 minus 3 by 2 z plus 1 by 2 z square, like cubic square a degree, take a equation in the calci, and then order 2 you have to put. Coefficient of this can be written like 1 by 2 z square, obviously it is z raised to minus 2, but take it as half x square plus minus bx, okay, plus 1. So enter x square coefficient as 1 by 2, x's coefficient a's coefficient as 1 by 2, b as minus 3 by 2, and c as 1. That is, this is a, b and c, which is x square's coefficient, this is x coefficient, and it is a constant. Okay, enter like this and get the parameters roots of it. So you get one as 1 by 2 and another one is as 1. Therefore, this equation can be expressed in terms of factors. Okay, 1 minus 3 by 2 z raised to minus 1 plus 1 by 2 z raised to minus 2 can be expressed as 1 minus 1 by 2 z raised to minus 1 into one more factor, that is 1 minus z raised to minus 1. So now observe the numerator order and denominator order of z. So when you have observed, denominator order of z is greater than your numerator. Denominator has 2, numerator has 1. So 2 is greater than 1. Therefore, we can go for a simple normal partial expansion, that is x of z equal to a divided by one factor, that is 1 minus 1 by 2 z raised to minus 1 plus another factor is b divided by 1 minus z raised to minus 1. You can go by like this also, a divided by this, b divided by this. It is up to you. Now we have expanded. Take a LCM of this term. Let's take a LCM of that term. So cross multiply. To take that LCM, we have to cross multiply this. Okay, x of z place you can substitute here, which is this one. Okay, cross multiplied, and then this two denominator gets cancelled. In the numerator of left hand side, it will be minus 1 plus 5 z raised to minus 1 equal to this term. So we have to get what is the value of a and b. For that, put z raised to minus 1 equal to 1, and to make this a equal to 0, and put z inverse is equal to 2 to make b equal to 0 by making those two. Okay, put 1, that is z raised to minus 1 equal to 1. Why we have to put? Because a term we have to bring it to 0. That time b will be present and get what is the value of b here. So let's put in entire equation z inverse is equal to 1. So it is minus 1 plus 5 into 1, it will be 5 equal to a into 1 minus z raised to minus 1 is 1, 1 minus 1 is 0, so a is 0, plus b 1 minus 1 by 2 into 1, so it will be 1 minus 1 by 2, that is nothing but 1 by 2. b is equal to 8. Similarly, make b equal to 0 and get a value. So to make b equal to 0, what value we supposed to put? Z inverse value should be put as 2. When you put this, it will be 2 get cancelled, 1 minus 1 will be 0. Therefore, in this part, minus 1 plus 5 into 2 equal to a of 1 minus 2 plus b is 0. So simplify this. Minus 1 plus 10 is 9 equal to a 1 minus 2, which is minus a is equal to minus 9. So therefore, take those two values and substitute. X of z is equal to a value is minus 9 divided by that factor plus 8 divided b divided by that factor. Substitute 8 divided by 1 minus z inverse. Let's take z inverse z transform for this. I hope we are familiar with this, that is 1 by 2 raised to n into u of n's z transform is 1 divided by 1 minus 1 by 2 into z raised to minus 1. Very familiar with this. And what is z transform of u of n? Z transform of u of n is nothing but 1 divided by 1 minus z inverse. So these two are here only, 1 divided by this term and 1 divided by this term. Only constant terms are there along with those two. Okay, therefore inverse z transform for this particular signals will be constant minus 9 as it is. This is nothing but 1 by 2 raised to n into u of n. Okay, similarly 1 divided by 1 minus z inverse is nothing but u of n. So therefore 8 into u of n. To get inverse z transform, we are a bit familiar with z transform first. Okay, so let's deal with another numerical that you will get to know how we can identify it easily. Okay, and then next we'll be taking another example which gives us, which they have asked us, x of z is equal to 1 by 4 z inverse divided by 1 minus 1 by 2 into z raised to minus 1 and 1 minus 1 by 4 into z raised to minus 1, where this ROC is greater than 1 by 2. In earlier case, ROC was greater than 1, so there was not much difference. Okay, but here we have a greater than 1 by 2. It might be, it means that ROC might be less than something. Okay, which is, when you say which is greater than 1 by 2, it might be possible of greater than less than also some values. So let's get, so then meaning of this one will be, it may be have one side or left hand side or right hand side of your signal, means our entire z plane, or it might be two-ended signal. So let's get how it might be. First let's concentrate on to get inverse of this. Since numerator and denominators orders of a z is what, denominator's order of z is greater than your numerator, therefore we can go for normal partial fraction, that is x of z is equal to a divided by one factor and plus b divided by another factor. Therefore let's get x of z is what, it is 1 by 4 z raised to minus 1. So cross multiply this, a into 1 minus 1 by 4 into z inverse plus b into this term divided by this denominator. So these two get cancelled. So what we get is this term 1 by 4 z inverse equal to a of this term plus b of this term. Let's get in this, to get a value and a b value. To get a value, we supposed to bring b value equal to 0. To get to get a b value, a term has to be 0. Let's make first b equal to 0 ताकि we get a first. So to make b equal to 0, put z inverse is equal to 2, so that this b becomes 0. So substitute in this entire equation z inverse equal to 2. So 1 by 4 into 2 will be 1 by 2 equal to 1 minus 1 by 4 into 2 is again 1 minus 1 by 2 is nothing but 1 by 2. B anyhow we made equal to 0. Therefore a equal to 1. Similarly, to get a b value, a has to be 0. To get a has to be 0, what we have to put, z inverse is equal to, what value we have to put to get a b value equal to 0, a value equal to 0 is, if you put z inverse is equal to 4, then 4 get cancelled here, then 1 minus 1 will be 0. So a term will be 0. So to get the other terms, 1 by 4 into 4 will be 1 here, and then 1 minus 1 by 2 into 4 is 2 ones are 2 twos are 1 minus 2 is minus 1. Therefore b equal to minus 1. So now we have got x of z, that is a divided by that term is nothing but 1 divided by 1 minus 1 by 2 z raised to minus 1, minus I'll take because b was minus 1. So here only we'll write minus 1 divided by another factor is 1 by 4 z raised to minus 1. If we have, if they have not mentioned any now they have said ROC is greater than 1 by 2. When they said ROC is greater than 1 by 2, what we can do is, this is belongs to, since ROC exists outside the circle of a radius 1 by 2, okay, here you can observe the ROC is greater than 1 by 2. It means it exists outside the circle of a radius 1 by 2. Okay, which exists outside the circle of 1 by 2. Therefore in the entire z plane, the corresponding x of n should be bring sided sequence. Therefore sequence corresponding to both the terms will be, both the terms should be of positive sided. Therefore your x of n will be, for this particular equation, when we have ROC is greater than 1 by 2, so remember it should have a both the sides should be positive. Therefore first one can be written as this is nothing but 1 by 2 raised to n into u of n minus as it is, okay, it is 1 by 4 raised to n into u of n. This is first case. Okay, this is the first case. Second case is ROC if ROC is less than 1 by 4. Okay, that is also possible because of this reason. Because of this reason, 1 by 4, your ROC will be less than 1 by 4. Therefore, what we can do is, so since if you say ROC is less than 1 by 4, then it should be inside the circle. Your ROC should be inside that 1 by 4th circle. Okay, the corresponding x of n must be left sided sequence when you have ROC within this. Okay, when you have ROC within the circle, then the sequence should be left sided, that is a negative side. This side your signal should be present. Therefore, your x of n will be corresponding to the left side. Therefore, it should be minus. Therefore, it is u of minus n minus 1. U of minus n minus 1. Therefore, it should be written as minus 1 by 2 because your value should be negative. Therefore, minus 1 by 2 raised to n into u of minus n minus 1 plus 1 by 4 raised to n into u of minus n minus 1. Okay. So, this is when the ROC is less than, when the ROC is greater. When the ROC is greater, then it is a 1 by 2, your ROC is outside the circle. Therefore, it should be positive. Now, ROC is inside the circle. Therefore, your x of n is left hand sided. Suppose if ROC is between these two, okay, that is x of z is between 1 by 4 and 1 by 2, then signal should be of both the sided. Okay, signal should be present from both the sides. Then we are going to take this signal as first one will be taking to a negative side, this side signal, and another signal will be taking at right hand side signal. So since this signal is between this value and this value, we have to be present both the signals to be at both the sided signal. Therefore, your x of n will be equal to minus 1 by 2 raised to n into u of minus n minus 1, and another signal is positive side, which is anyhow b was minus, so minus 1 by 4 raised to n into u of n. Okay, so now we'll see the another example which has division, like which has numerator has a more value or equal to the denominator order of your z. So this is x of z, which is equal to 1 plus 2 z raised to minus 1 plus z raised to minus 2 divided by 1 minus 3 by 2, 1 minus 3 by 2 z inverse plus 1 by 2 z raised to minus 1, where z is greater than 1. So whenever we have z is greater than 1, we not have any problem because this and ROC will be outside that circle. Okay, outside of that 1. So therefore entirely will be positive sided signal. So now we'll be concentrating on how to get x of n. So observe, you can factorize first and then we can observe. So get numerator order of a z is 2 and denominator's order of a z is also 2. When these two are equal, we are not able to apply direct partial fraction method. So what we have to go for? A long division method we have to go. How we can do it? That is a very simple thing. What we have to do? Just divide this signal by this particular signal. So let's get, this will be, divide this signal, that is 1 by 2 raised to z raised to minus 2 minus 3 by 2 z raised to minus 1 plus 1. This signal we have written like this. So this signal will be, numerator signal will be, we have to take z raised to minus 2 plus 2 z raised to minus 1 plus 1. So divide this to get here 1. How much you have to multiply with this? It has to be multiplied with 2. If you multiply 2, if you multiply 2 with this signal, you get z raised to minus 2. Okay, 2 into 1 by 2 is 1, it is z raised to minus 2. Okay, and then minus 2 into 3 by 2 is 3, z raised to minus 1. 2 into 1 is plus 2. So just simplify this. Here plus plus is there, change the sign of it, minus, change the sign of this, it will be minus, here it will be plus and it will be minus. So z square minus z square will get cancelled. 2z raised to minus 1 plus 3z raised to minus 1 is 5, z raised to minus 1, plus 1 minus 2 is minus 1. Okay, therefore what we can do is 2. Therefore this x of z can be written as 2 plus, okay, 2 plus this whatever remained, which is 5z raised to minus 1 divided by this term, which is 1 by 2 z raised to minus 2 minus 3 by 2 z raised to minus 1 plus 1. Okay, this is signal. So now whatever we have got, this is signal. 2 is a constant term, you keep as it is. Consider only second factor. Let's take this one as x1 of z. Okay, observe numerator has 1z and denominator has 2z. Therefore 2 is greater than 1. Now we can apply simple, that is a normal partial fraction for this second factor only. Okay, now let's take, since we have taken that as x1 of z, that is nothing but 5 z raised to minus 1 divided by 1 minus 1 by 2 z raised to minus 1 into another factor 1 minus z raised to minus 1. Take this expand in terms of partial fraction, a divided by this factor plus b divided by this factor. Cross multiply this. Okay, a into this, a into 1 minus z raised to minus 1 plus b into 1 minus 1 by 2 raised to 1 by 2 into z raised to minus 1. Okay, take this LCM and then cancel these two denominator, only remain terms is this. So to get a value, put b is equal to that, put z raised to minus 1 is equal to what value we have to put? 2. If you put z raised to minus 1 value 2, then b terms will be 0, then we get a value. And then to get a b value, what we have to do? A value should be 0. For that, put z raised to minus 1 equal to 1. Now by substituting this z raised to minus 2, it will be 5 into 2, that is 10 minus 1 equal to, so a of minus 1 minus 2 is minus 1 plus b terms is 0. So 9 equal to minus a, so therefore a equal to minus 9. Then put z inverse equal to 1 to make a value equal to 0 to get a b value. So a value equal to, z raised to minus 1 equal to 1, then this term will be 5 minus 1 equal to a is 0 plus 1 minus 1 by 2 is 1 by 2. Therefore b will be equal to 8. Therefore x1 of z is my a value minus 9 divided by term plus b 8 divided by 1 minus z raised to minus 1. So we have got this, right? But x of z is 2 plus x1 of z. 2 plus x1 of z is this term. Now taking inverse z transform, as we know z ROC is greater than 1, means entirely right sided signal you get. Okay, 2 is a constant term, you get a 2 signal that is at delta n. Okay, therefore the inverse will be 2 delta of n. So here minus 9 into what is 1 divided by 1 minus 1 by 2 into z raised to minus 1, it is nothing but 1 by 2 raised to n into u of n, plus 8 is a constant term, keep as it is. This is 1 divided by 1 minus z raised to minus 1, as inverse is u of n. Therefore x of n is our 2 delta of n minus 9 delta 9 into 1 by 2 raised to n u of n plus 8 u of n.